So this is section 9.8, and this is all about the parent function for a log graph. Okay, so if I were to put this in my calculator, and you don't need to put it in yours, but if I were to put this in my calculator and graph this first one, log base 2 of x, it would go through the x-axis right here and look something like that. Okay, again, if I were to put this next one in my calculator, the only difference is the first one was base 2, the second one is base 3. It would still go through this point on the x-axis, and it would look something like that. Whoops, mine doesn't quite go through that point, sorry. And if I were to put the last one in, log base 7, it would still go through that point, but it would level off a lot sooner, something like that. So when you look at these, all of these are log graphs. They all look very similar with just slight differences. So let's kind of do a comparison. What do we notice about the graphs? Well, number one, notice on all three of them, the x-intercept is the point 1, 0 on each of those graphs. On this one, we might say, is there an asymptote? Well, remember on the exponential graph, we had a horizontal asymptote, but it looks like on each of these that there's a vertical asymptote. Do you see that all three of these graphs, no matter what the base, they leveled off at the y-axis. They never crossed over the y-axis. So we're going to say, yes, there is an asymptote. In fact, it's a vertical asymptote. Okay, and in this case, since all of them are on the y-axis, the equation for that vertical line would be x equals 0. Okay, so that would be the equation of the vertical asymptote. So it's something interesting where the exponential graph, and I'll just kind of put this down here as a note, the exponential graph, they have a horizontal asymptote at y equals 0, but the log graphs, they have a vertical asymptote at x equals 0, meaning the basic parent function has that horizontal or vertical asymptote. Okay, so something to keep in mind, what do we know about logarithms? Well, you cannot take the log of 0. In other words, if I have, let's say, how do I want to think about this? If I look at these graphs up here, these are log graphs. And remember, the equation is such that it's something like y equals log, whatever the base might be, of x. Okay, so notice on these graphs, the x values are always positive. Like on these graphs, the x values are always positive. The graph only exists on the right side of the y-axis. The graph never touches the y-axis, which is where x equals 0. So because of the fact that there's a vertical asymptote there, it makes sense that x cannot equal 0 on this basic log graph. So that's why we'll never ask you to take the log of 0. If you do, you just know it's undefined. Same thing is true for a negative. Again, since these log graphs only exist on the right side when x is positive, you'll never be asked to take the log of a negative number. Again, it's undefined. And then finally, remember back when we first learned about exponential and logs, we said the log of 1 always equals 0, which makes sense because on the graphs up above, didn't they always go through the point 1, 0? So that means when x is 1, y is 0. And remember, that is the x, that is the y. Okay, so let's talk a little bit more about this as a parent function. So remember all of the transformations that we learned way back when, and we reviewed again in the last section. So when I look at this, the fact that it's a log graph means I'm thinking about the basic parent function that looks something like that. And then because of that +1 on the inside, I'm going to move the entire graph 1 unit to the left. So that means the point that was right there at 1 is now over here at 0. So that same basic shape, okay, that one's a little bit fatter, sorry. that same basic shape. It's just moved to the left. On this one, remember the basic parent function goes through right here. It does something like this. But it's moved 2 units to the right. So from 1, if I go 2 to the right, now I'm at 3, and then up 3. So that point that used to be, right there at 1 was moved to the right and up. So now that same basic shape, it's just moved over and up. Now, something I want you to think about, remember we said the basic parent function has a vertical asymptote at x equals 0. But since this entire graph, I'm looking at letter A, since this entire graph was moved to the left 1 unit, that means the asymptote is also moved to the left. So think of it this way, where the asymptote used to be right here, let me do it this way, where the asymptote used to be right here, if I move that 1 unit to the left, it's going to move it right there. So now the asymptote is over there at -1. On the first one, again, where the asymptote was originally right here on the y-axis, if I move the entire graph to the right 2 units, then that asymptote is moved, that asymptote is moved to the right 2 units. So if I take that graph and I move it to the right 2 units, it's going to be right there. So again, you can see that the new graph levels off right there at x equals 2. So what does that mean? Remember on the horizontal asymptotes, on the exponential graphs, we said, let me write it right here. When we have an exponential, let's say y equals, 2 to the x, that was an exponential graph. If you have a number out here at the end, then remember what we said last class, that is going to be your horizontal asymptote. In this case, y equals 1. Okay. Well, in this case, on log graphs, because we're moving a vertical line to the left or right, the vertical asymptote is not going to come from the number at the end, but the vertical asymptote is going to come from the number inside the parentheses. And it's always going to be the opposite of that number, because remember, we move it the opposite direction, right? If it's a minus, we move it to the right. And if it's a plus, we move it to the left. So in this case, the vertical asymptote is x equals +2. Or on this one, we would say the vertical asymptote is x equals -1. And you can see how those lined up on the graph. Okay, so let's think about domain and range. Okay, so again, on this, we are looking at the pink graph. That's our final graph. Remember that blue is just our original. Okay, so on this one, that pink graph, what's the domain? Well, how far to the left does this graph go? Well, the farthest it goes to the left is that vertical asymptote at -1. How far to the right does this graph go? Well, it's going to continue on out to infinity. Whereas the range, the graph is going to go down forever. And even though it almost looks like it levels off, it's still going to gradually keep going up. So it goes to +infinity. On this one, again, we're looking at the pink one. That's our final graph. For the pink one, how far to the left? Well, the farthest to the left it's going to be is 2. And it's going to go on out to the right forever. And then the range, how low does this graph go? Well, it's going to continue down forever. And again, even though it looks like it levels off up here, it's going to gradually move up the further you go out. So it's going to go up to +infinity. So notice on these, on log graphs, it's the range that is -infinity to +infinity. Okay, on log graphs. Remember how in the last section when we had exponential graphs, it was the domain where that happened, where it went from -infinity to +infinity. So just, again, something to kind of keep in mind. Okay, so what's the best way to approach these graphs? Well, if I were you, I would put the vertical asymptote on first. Remember, these are logs, so we know they're going to have vertical asymptotes. And we said the vertical asymptote comes from the number on the inside of the parenthesis, and it's always the opposite. So in this case, it's going to be x equals +1. Okay, when you look over here at letter C, notice there is no number on the inside. So that means it's just a 0, or the y-axis. Same thing here. Notice there is no number on the inside. So it's just going to be on the y-axis, which would be x equals 0. Okay, so let's talk about the basic graph. So I'm going back over here to letter C. Remember, the basic log graph before you do anything to it is right here, going through 1 and kind of leveling or heading out that direction. Okay. On this particular graph, because of the negative on the inside, remember, if the negative's on the outside, you flip it across. Let me put it this way. If the negative's on the outside, you would go across the x-axis. This is what we learned last time. But if the negative is on the inside, wherever the x is, that's where you're going to go across the y-axis. Okay, so on letter C, if I take that green graph and I just fold it across the y-axis, do you see that instead of going through +1, it's going to be going through -1. So if all I do is fold it across the y-axis, it's doing something like this. Okay, so I just flipped it across the y-axis, but I'm not done with this graph because now it says to move the whole thing up 1. So that point that used to be down there on the x-axis is going to go up 1. So the entire graph just gets moved up 1. If I could get it just to the right spot. Sorry. There we go. Okay. So it was moved up 1. All right. So look at letter E. So this time, instead of drawing the original, I'm just going to, well, I'll draw it so we can think it through. So remember, the basic graph is like this. Okay, this time there's a negative out in front, so I'm going to flip it across the x-axis. So imagine if you were to fold this on the x-axis, it's still going to go through that point, but now it's still going to go through that point, but now it's going to be coming this direction. Can you picture that? That's what it looks like if you fold it across the x-axis. Okay, so there I've folded it across the x-axis. And now I want to move the whole thing 1 unit to the right. So if I move this whole thing 1 unit to the right, that point that used to be there at 1 on the x-axis, it gets moved over 1 unit. And so now it's right there. And you can tell when you get it in place that makes sense where you have your vertical asymptote. Okay, on letter F, it says, I want to flip it both directions. Okay, so just so we can kind of have in our brain, here's the original. Okay, if I flip it, and it doesn't matter which one you do first, X or Y. If I flip it across the X, it's going to be coming this direction. Oops, if I could draw it, sorry. It's going to be coming this direction. Okay, that's across the X. Now take that one, and I'm going to flip it across the Y. So now it's going through over here and coming this direction. So that's the graph that's been flipped not only across the X, but also across the Y. Okay, so this section is all about the parent function log, and you can shift it up or down or left or right or whatever, right? Flip it across the X, flip it across the Y. Just make sure you notice in the homework, 1 through 6 are all practicing shifting that parent function, that log parent function, but then 7, 8, and 9 are a refresher of the previous section for the exponential graph. So make sure you notice the difference in those.